All right, so today we're going to spend a little bit of time labeling waves and practicing how to label waves. This is important because we use waves all the time, whether it's through lights and visibility or cellular telecommunications or just speaking. As I speak, I'm producing waves. And so it's important to be able to label waves so that we can communicate clearly and effectively with one another about what we are describing. So the first point on a wave that we're going to talk about is the peak. So here is a peak, and here is a peak. And we call the upper peaks the crest, and we call these lower peaks the trough of the wave. We use crests and troughs to measure the length of the wave, and we call that distance the wavelength. Sorry about that. So if I go from this point to this point, the highest point on the wave, to the highest point on the wave, this distance here is called the wavelength. And the wavelength is from one point on a wave to the identical point on the next wave. So we usually measure that as crest to crest, or from trough all the way over here to trough. But you could also measure that from this point on the wave to this point on the next wave. If you notice, my wave's moving down, and over here my wave is moving down. I can't measure it to right here because my wave is moving up there, so this would be half a wavelength. To measure the full wavelength, I need to go from this point to the identical point on the next wave. So that's how we measure the length of the wave, which again we call the wavelength. Let me go ahead and erase this. And the next thing that we can measure is the period. And the period of a wave is the time it takes for one whole back and forth motion. You can think of this also as the time for one whole wave to pass. So maybe my period is 3 seconds. So it takes 3 seconds for this whole wave to pass. We use that to help us measure another property of waves called the frequency. And frequency you've probably heard of if you listen to the radio. You turn your radio dial to a certain frequency and you get a radio station then. And so the frequency is the number of whole waves per second. So if my period is 3 seconds, meaning it takes 3 seconds for this whole wave to pass, my frequency would be 1/3, and we measure this using units called hertz. If you notice, I can calculate my frequency by taking 1 and then putting that over the period. All right, so that is period and frequency, two ways that we can use to measure and describe waves and the amount of energy that we find in waves. The next thing that we're going to talk about is wave speed. And this is simply how fast energy moves through a medium. It's important to note that frequency and wavelength don't actually affect the wave speed. The medium that the wave is moving through determines the speed. So we talk about how light has a speed. We measure things using the speed of light, and we say the speed of light is constant. But we actually know that light does change speeds, because if you've ever seen, like, if you've stuck a pencil in a glass of water and it looks like the pencil is broken, that is due to refraction and light changing speed just ever so slightly, and so then the light bends. Something else about wave speed, we measure wave speed by taking the frequency and multiplying it by the wavelength. So you can use frequency and wavelength to calculate the speed of light or the speed of any sort of wave. So as the frequency of a wave increases, the wavelength will decrease so that the speed stays constant. And another thing to remember is that waves can be thought of as just energy moving through something. So that is how we calculate wave speed. Amplitude is the next thing that we're going to talk about. And amplitude is the amount of displacement caused by a wave. So you can see, if you were to imagine a lake that's perfectly calm, there's no ripples on it, no wind, it's a really peaceful morning, and that is represented by this black line, or this dotted line, that nice smooth lake. But then imagine that a fish were to jump out of the water. It would create ripples, and the distance between that flat smooth water and the top is the amplitude. Now if you notice, from the trough to the crest, that is not the amplitude. That's the wave height, but the amplitude is from no ripple, no wave at all, to the crest of the wave, or you can think of it as half the height. Another really important thing to pay attention to, and I'll use a double arrow for this, is the direction of oscillation in a wave. So if you notice, I've got this wave here, and this is actually just a string of beads, or you can think of it as a slinky. And this green bead is not actually going to move down the wave. This green bead is just going to go up and down. This green bead is just going to go up and down. And that is called the direction of oscillation. Let me write it over here. Oscillation. And oscillation is the direction the particles of a medium move. So in this case, since this is a transverse wave, the particles are moving up and down. They are moving perpendicular to the direction of propagation. So here I can draw in this arrow, and this is the direction of propagation. The direction of propagation, let me write that, propagation is the direction the energy is moving. So here my particles are moving up and down. With propagation, the energy is actually moving left to right. This is a transverse wave, so propagation and oscillation are perpendicular to each other. In a longitudinal wave, such as a sound wave, the direction of propagation and the direction of oscillation are parallel to each other. So if the wave is moving left to right, the particles also move left to right. So those are all ways that we can describe waves and that we can communicate about waves. They are universal in the world of science, so make sure that you know how to describe a wave. And thank you very much for listening.